Go language programming, chapter 2, unit 2. Go language variable declaration scopes. Scope of a variable declares the visibility of a variable. If we declare a variable at the top of the source file, then this variable is visible from within the entire code of that file. Go language is built on the concept of blocks. So the block is a sequence of declarations and statements within matching pair of braces or brackets. So basically matching braces. So this is a braces. So it's a begin of the block, and this is the end of the block. Okay. So in Go language, the scope of a declaration is bound to the closest pair of the braces. So if I declare a variable num, then this variable is within this scope because it's within this braces. Okay. And it is closest to the pair of the curly braces, so it is in that scope. In Go language, the variables are local to the scope. So now this variable becomes local to this block. Okay. So what that means basically is when this memory for this variable num was allocated, that memory will be released as soon as the code is executed outside this block. So as soon as the code outside this block start executing, okay, so then this num will be released from the memory because the scope of this num is gone, no longer in the memory. So memory is released automatically. There are several scopes in Go language program. Okay. So Go language has a block scope, which we just saw it. Okay. This is the block scope within the curly braces. Okay, that's what we were just discussing. It has a function scope within a function body. So if you create a function and within the function body, so within the main, for example, in this example that we're going to be going over, there is a variable declared right here, days. Okay, and it is within the scope of this function main, which starts at line number 4 and ends at line number 13. So it is within the scope of this function main, this variable called days. Or it can have a file scope within a global within a Go language source file. So if it is a file scope, that basically means that the variable is available to all the functions which are within that file. Okay, so it is similar to like a global scope, but only that variable is going to be available within that file. And then, since the Go language supports the packages, so it has a package scope. Now, of course, we haven't discussed anything about the packages except for the FMT package, which is a standard library package. And the reason within that, from that package, we can use the functions because the function names start with a capital letter. That means those functions are available to the outside of the package. But if some variables are not going to be available to outside of the package, then they are considered unexported, and those variables or the function names will be starting with a small character. And don't worry about it right now. We will discuss the difference between exported and unexported functions or the variables from the package, okay, later on. So right now, just think about that. Packages are something that will will have some sort of a scope as well for the variables. And then there is a concept of a universe scope. That means globally declared exported variables. That means everything, every file will have the access of the variables. Okay, even if they are declared in a package. So they are globally available to every source file that you have for your project. That is called the universal scope. Okay. So now let's basically um, uh, try to understand um, by using this example 5 dash 2 dash 5 is to see how this um, um, uh, local scope to the function works. Okay, so it declares the days to be 100 inside the main. Main is a function, and inside the for loop also it is declared another days. Okay, so how this is done? So as we discussed that to any program to be executable, you have to have a package main. Okay, and the very first line in your source code. And we are importing the FMT package, so that's why line number 2 is there, because we want to be able to use the print line function. And at line number 4 we start the body of the main function with a func keyword and then the main function name, okay, which is the entry point for this program, and then a curly braces on the same line as the function name. So at line number 5, what we have is we are creating a short declaration. Okay, this is the short declaration because we are using a colon equals to. That means the memory will be allocated. Okay, the memory in the RAM will be allocated, and this memory will have 100 in it, and let's say it is allocated at some address location 010, f or something like that. That's a hex number memory location, and the label for this memory is days. Okay, so that's the memory will be allocated at line number 5. And this type of this memory is an integer type because we are initializing the data, which is an integer data, which is 100, to this variable called days. Now, this variable is in the scope of the this curly braces, which starts at line number 4 and ends at the line number 13. So it's in within that scope. Okay, so that is the memory allocated for that variable. Now we have a for loop which starts at line number 7, and in this case, we already have covered the for loop. So basically, for loop has a short declaration. Okay, and it has this for loop is a has a 3 sections: initialization section, comparison, and increment. Okay, which is similar to a C language. Now, at line number 8, in within the body of this for loop, so this is the body which starts at line number 7 and ends at line number 10. But within that body, we are creating another disk. So that will be at a different memory location. Okay, this days will be at a different memory location, at a different address, basically. So basically, you can just say uh, 8 a f address or whatever, and it will start with the 0 data. And since it's an integer variable, so that means it is going to be that count will be a type integer. Okay, and in this case, this days will be changed, but it is at a different place in the memory. So this days is not the same days as this one. They are both are at the different memory location, and it will be keep doing until this condition becomes false. Okay, meaning that count goes to equals to or greater than 5. Okay, as long as it's less than 5, then that means it's a true condition. It will be keep doing it in the for loop. Okay, and then of course we have a this call to this print line from this package fmt by using a dot operator. So that's why we get this printout right here, output. And then at line number 12 we have another print line, and in that case the days that is getting printed are these ones. Within the for loop body, these are the days that are getting printed out. Okay, so that's how the variable declaration scopes works in Go language. Okay, and the next that we will be discussing is the scopes and shadowing declaration, which is in this next slide. So here the scope and shadowing declaration in Go. So a variable is set to be shadowing another variable if it overrides the variable in a more specific scope. Okay, so that means the variable are shadowing. The variable, one variable is shadowing the other variable. So the Go language allows a variable, a variable uh, to be to shadow another variable in the same function. Okay, even if they are in a different block uh, scopes. So they don't have to be in the same block. So, you know, this is a block right here, right? And then there is another block right here. So they don't have to be in the same block. So that's why they can also do the shadowing. But there is a problem, but in that, that's how the shadowing basically works. So it can cause some issues if a programmer is not really careful, and then the shadowing will occur without the knowledge. So unless you in your program you want to be able to write a code that way to do the shadowing, but you can accidentally also you can do the shadowing, okay, uh, because if you use a short declaration with the colon equals to for another variable accidentally instead of just using a equal sign, then that means the data will be wrong. Okay, and these kind of errors will be very difficult to catch. So that's what in this example that basically has example number 2 dash 6. Okay, so in 2 dash 6 basically what we are going to see is how the shadowing works. So again, we have a package main, and then we import the FMT package, and then we create a main function body. It has a starting of the body at line number 4 with the curly braces and ends at line number 16, and then within the body at line number 6 we do the short declaration of a variable called days. Now as you can see, the days will be of type integer because we are initializing it with the 0. Okay, and then within the body of a for loop we are basically creating another days right here. Okay, but the problem here is that the intention was to use a equal sign right here, but by mistake a programmer end up using a colon equals. So when you use a colon equal, what happens? You get a two memory locations, okay, at a different addresses. So this might be at address 1000, okay, and this might be at address 2000, and basically this this is a days also, and then this is a days also, but at a different location. Okay, and it happened because of line number 6 and line number 12. Okay, line number 12 is a mistake. It's supposed to be just an equal sign. Okay, so but since it's not an equal sign and it is a colon equal, that means it's a short declaration, and it will create this right here. Okay, and it in this case, when the for loop is keep coming, this days right here will be always be using or will have 0 as a content. Okay, which is initially, let's say this was that we created this days which initialized with the zeros. This is line number 6. Okay, this is line number 6 days, and then this is line number 12 days. So basically, um, in case of coming back in the loop again and again, since this will always be a 0, so 0 plus 1, okay, will be 1. So first time when it comes within the body of the for loop, and it sees this print line, and it will print right here a 0 because of this days. Okay, and then it comes here and which does the shadowing by mistake, by accidental, then basically this days, as you saw the data, it will be a 0, which is right here, the output, and you add 1 to the right at this memory address. So it will add 1 to this days, okay? And then, so this one will be printed right here, okay? That is shadowing counter. And then when it goes back up to the for loop, because of the condition is still true, so it will go back. Then when it comes to back here, it will still have a 0, so it will print out 0. And then it comes to line number 12, and at line number 12, 0 plus 1 is 1. That will be initialized to this one again with the 1. Okay, so that is the problem. Now if you rewrite this line, at line number 12, and remove this colon equals to, and make it just a equal, then there will be only one memory for days. The other memory, this one will be gone. Okay, so then in that case, this will be incrementing properly, so start with 0 plus 1, so that will be 1, and then the next one will be a 2 and 3 and 4, like that. So it will be the correct basically it will give you the correct answer. Okay, so that's how the shadowing works, and shadowing can cause issues in terms of or this is basically it's called the semantic error. Okay, the reason it's a semantic error is because um, you would not really know that there is an error like this, because you will compile the code and run it, and you would not really see it unless you carefully watch the output of your data. Okay, then you will know the numbers are not coming out right. So then you will have to go and look for the bug, and this kind of a bug will be very, very difficult to find. Okay, so this basically concludes Unit 2, Chapter 2. Okay, so we will